Good morning. The Subcommittee on Research and Technology will come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled Surface Transportation Technology Driving the Future. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witnesses. I now recognize myself for 5 minutes for an opening statement. The products that flow through our networks of highways, railroads, and pipelines are the lifeblood of our country's economy, and the nation's transportation infrastructure is the vital network through which it must flow. Consequently, dollars spent on the research and development and technology activities of the Department of Transportation are essential to the nation's prosperity. These efforts support critical infrastructure and enhance both a healthy economy and the most efficient transportation system that our technology can provide. Today's hearing provides the committee with an opportunity to examine research and development priorities at the department and to understand the important policy issues regarding the future of surface transportation. We hold this hearing amidst the ongoing efforts to replenish the Highway Trust Fund and make for long-term investment and planning. I'm intimately familiar with these concerns because in addition to my role as chairwoman of the subcommittee, I also serve on the House Committee on Transportation and Infrastructure, and I also live in a district filled with a diverse group of transportation challenges, from highway construction to metro and airport issues. Transportation funding challenges are not just a transportation policy issue, but a science and technology issue. We know that the technology industry can provide us with breakthroughs for more efficient uses of our transportation dollars and better results on the ground. A shortfall in research and development funding would have real-life consequences on technological advancements involving not just cars, trucks, and trains, but highways, bridges, and pipelines also. Later today, we'll hear more about one such exciting technology from one of our witnesses on the topic of autonomous cars. But while we may be several years away from the world of driverless cars, another important technology that can save lives already exists today. By law, positive train control, or PTC, technology is required on 60,000 miles of railroad track by the end of this year. The benefits can't come soon enough, as evidenced by last month's Amtrak derailment outside Philadelphia. Positive train control technology, we heard in the Transportation Committee recently, would have stopped that train from taking that 50-mile-an-hour turn at a speed of 106 miles per hour, and obviously would have changed the devastating results in that case. While Amtrak is on schedule to meet the deadline to implement PTC for its Northeast Corridor by the end of the year, there are other railroads that have told us to date that they can't make that deadline. Closer to home, our nation's metro system suffers from outstanding safety issues that require continued vigilance by Congress, as well as the full support of the federal government for technological upgrades that would benefit many of us here in the room today. Today's hearing will also provide the committee an opportunity to understand research and development activities in surface transportation, both at federally sponsored research institutions as well as the state-level entities, such as the one representing the University of Virginia. I look forward to hearing everyone's testimony today and to engage in a productive and fruitful discussion on U.S. surface transportation, research, development, technology, investments, priorities, and policies. I also look forward to continuing to work with many of you to maximize the effectiveness of the research and development that Congress does as we reauthorize the federal surface transportation programs. Thank you all for joining us today. And I now recognize the ranking member, the gentleman from Illinois, for his opening statement.
Thank you, Chairwoman Comstock. Thank you for calling this hearing. And one other thing, can you fix Metro for us?
We're all working together on that.
Do everything I can. I'm riding it every day out here. I appreciate the witnesses for being here, and I look forward to their testimony. Whether by car, train, bus, or foot, we all have to rely on transportation system for our daily commutes and longer distance travel. When it works, everyone's happy. But when it doesn't, the results can range from annoying to catastrophic. With the U.S. population predicted to increase by nearly 30% by 2050, we have to find ways to move people and freight more efficiently and more safely. Our current system of roads, bridges, railroads, and transit lines, will not be sufficient to support the additional influx of people. In some instances, it's not sufficient right now. This is something we struggle with on the Transportation Committee, which both the Chairwoman and I serve on. But the answer will not simply be building more and bigger, because it is not clear that we will have the funding, the popular support, or the land to do that. So what do? Well, surface transportation used to be rather staid and unimaginative. Some might say boring. But today, through research and innovation, the very concept of mobility is being reinvented. This is the key to meeting the transportation demands of our nation. And we in Congress must do our part to help the researchers, innovators, and entrepreneurs revolutionize transportation. As an engineer, this is something I've been interested in and involved in during my 10-plus years on this committee. And the rapid advances that are being made, I'm very interested to hear from our witnesses about today. The research title of the upcoming Surface Transportation Bill provides an important opportunity for this committee to provide more guidance to the Department of Transportation on national transportation R&D priorities for highways, public transportation, rail, and freight. As I discussed in my recent op-ed in The Hill, we have to make federal investments in research that will provide a safer and more efficient transportation system for future generations. Long-term transformational research must be prioritized in the federal budget. We have to ensure that our federal research partners, particularly university transportation centers, are able to conduct advanced research. I have drafted a bill that will help us to do that and help the U.S. usher in a new age of transportation innovation. I look forward to hearing the panel's thoughts in this direction. I recently convened an advanced transportation technology roundtable in Silicon Valley, in which I heard from OEMs, Tier 1 suppliers, and tech startups. While we talked about new ideas for making mobility more efficient, more environmentally friendly, and more available to everyone, a common theme was the need for improved connected infrastructure and information technology capabilities. Cars talking to each other was once a thing of science fiction. At a Connected Car Coalition Roundtable I spoke to in March, automakers, the telecom industry, and the DOT all agreed that this technology is now at hand. This includes wireless communications that can help cars see around corners. The 5.9 gigahertz spectrum that is currently reserved for transportation safety communication can prevent up to 80% of crashes, according to NHTSA. It is important that this spectrum can be used to prevent accidents and save lives. Next on the horizon are autonomous vehicle systems. This week, the National Transportation Safety Board recommended that all new vehicles be equipped with active collision avoidance systems. And Google has indicated fully autonomous cars could be only 5 years away. As we will hear from Delphi, they drove a vehicle across the U.S. that was autonomous for 99% of the time. Until that very challenging last 1% of automation is achieved, more work is needed, including human factors research to understand how drivers will re-engage with driving after being engrossed in their phones or a movie for an extended period of time. These technologies incorporate findings from many areas of basic research and related technologies that have been funded for decades by agencies such as NSF, NIST, NASA, and DoD. It's not difficult to imagine how planetary rover technology for space exploration and how defense robotic technology is playing a part in advancing driverless car technology. It is imperative that the Department of Transportation continue to actively collaborate with other agencies to help translate this research into advances in autonomous vehicles. Finally, among the issues I think need to be addressed is freight research. I represent part of Chicago, a city through which 25% of all freight travels at some point in its journey across our nation. Freight volume is projected to increase by 25% by 2025. Freight movement is a national problem, and we need a federal research program to address these challenges. I hope Mr. Winfrey and Dr. Meyer will let us know what Congress can do in the next reauthorization to help the Assistant Secretary advance these and other modal administration's research recommendations. Identifying the research priorities for the nation's transportation system is critical to the safety of our citizens and our economic competitiveness, and the Committee on Science, Space, and Technology has an important role to play. Again, I want to thank the Chair for calling this hearing and look forward to the witnesses' testimony on this important subject.
I recognize the chairman of the full committee, Mr. Smith.
Thank you, Chairwoman Comstock, again for holding this hearing, and appreciate the witnesses who are here and look forward to their testimony. The future of America's transportation systems depends on the effective development and use of new technologies. Technology enhances the capacity and safety of our roadways, railways, and other transportation systems. Technology can relieve traffic congestion and enable our pipelines to safely transport hazardous materials. This will boost economic efficiency, reduce cost, and improve productivity. The federal government's investments in the transportation network should be targeted to achieve desired outcomes. The Department of Transportation's current 5-year Research, Development, and Technology Strategic Plan merges Congress's priorities from the 2012 Transportation Bill, commonly referred to as MAP 21, with the Department's strategic plan goals. It creates 5 research, development, and technology priority areas for fiscal years 2013 to 2018. Those include promoting safety, extending the life of future transportation systems, improving the movement of goods, reducing congestion, and improving mobility and protecting the environment. If we focus on smart priorities, the investments we make today will improve the future of transportation. Cutting-edge concepts encompass a broad range of information and communications technologies that have the potential to improve the safety, efficiency, and performance of our nation's transportation system. The issues before us today touch on all modes of surface transportation and impact every American. High-priority research and development will not only help create autonomous automobiles and improve crash avoidance and other safety technologies, it will also lead to better roads. Some examples include the use of nanotechnology to create new and better road surfacing materials and the development of new means of integrating multi-mode transportation. This will allow Americans to navigate the roads more easily and comfortably. It is essential that we find a way to maintain a healthy, substantive research base for our state and local transportation initiatives. We have to ensure that Congress gets its priorities right and avoid duplication of research in order to ensure taxpayers receive maximum value for their hard-earned tax dollars. This makes the committee's jurisdiction over the research, development, and technology programs at the Department of Transportation particularly relevant. Thank you, Madam Chair. Again, look forward to our witnesses.
Thank you, Mr. Chairman. And I now recognize the ranking member of the full committee for a statement, Mrs. Johnson.
Thank you very much, Madam Chair, for holding the hearing. Thank our witnesses for being here. This hearing was called to review research and development programs at the Department of Transportation and to review the relationship between the department and non-federal entities that also conduct transportation research. Last year, almost to this day, the committee held a hearing to examine the impact of research and technology on the future of transportation. These are very general topics, and it is good to have a general overview now and then. However, I hope we will also have the opportunity to move and look more thoroughly and examine more thoroughly specific transportation R&D topics in this Congress. As a member of the Science, Space, and Technology Committee and the Transportation and Infrastructure Committee for 22.5 years now, I am keenly aware that transportation disasters have been filling the news over the last several weeks. My thoughts and prayers are with the victims and families affected by the fatal Amtrak crash in Philadelphia last month, my Dallas district and surrounding areas of North Texas, overwhelmed last month by days of heavy rain, where one night 7 inches of rain fell and shut down roads for days, and of course the rest of the state. Having a district that has 5 interstates crossing it, Interstate 20, 30, 35, 45, and 635. I'm keenly aware of how much we need research to make sure that when repairs are done, they can stay in place. With respect to pipelines, the PHMSA inspectors have found that there are 54 to 74% corrosion of the pipeline wall. In last month's rupture that spilled 100,000 gallons of crude oil along the California coastline. In light of these recent events affecting our rails, highways, and pipelines, there are a number of technology issues on the minds of our constituents and this Congress as we consider reauthorization of surface transportation programs. We must keep that in mind. We're living in a time that is truly transformational for all modes of transportation. When I think about the potential benefits of connected vehicle technology, I don't think it's too lofty to compare its potential impact to the impact of the Eisenhower Interstate Highway System 60 years ago on connecting goods and people across the nation. As our population grows, so too is access to public transportation and ride-sharing options. From highways, public transportation to railroads, research and development of innovative technologies and policies can improve the safe and efficient movement of people and freight. My district also has an inland port. It is equally important to implement policies and support long-term advanced research that will lead to revolutionary improvements to our transportation systems. To ensure tech-savvy transportation workforce, it is also important that we implement policies to incorporate transportation applications in the teaching of STEM fields. My colleagues and I must come together to support a multi-year bipartisan surface transportation reauthorization bill that includes strong R&D provisions with adequate funding levels. I only hope that the Science, Space, and Technology Committee will take the steps necessary to ensure that we have a strong voice in what the bill looks like. Again, I thank our witnesses for being here today, and I look forward to your testimony. Thank you, and I yield back.
Thank you. At this time, I would like to introduce our witnesses. Our first witness is the Honorable Mr. Greg Winfrey, Assistant Secretary for Research and Technology for the Department of Transportation. He has also served the department as the agency's Chief Counsel, Deputy Administrator, Acting Administrator, and as Chairman of the Department of Transportation's Innovation Council. He is also an avid motorcycle rider and founding member of the USDOT Triskelion Motorcycle Club. That's very exciting. Mr. Winfrey earned a BS degree in Communications and Public Relations from St. John's University and his law degree from Georgetown University Law Center. Our second witness is Dr. Michael Meyer. Dr. Meyer is the chair of the Research and Technology Coordinating Committee for the National Academy's Transportation Research Board and a senior advisor for Parsons Brinkerhoff. Prior to holding these positions, Dr. Meyer was a professor of civil and environmental engineering and chair of the School of Civil and Environmental Engineering at the Georgia Institute of Technology. Dr. Meyer has earned 3 degrees in civil engineering, his bachelor's from the University of Wisconsin, his master's from Northwestern University, and his PhD from MIT. Our third witness is Dr. Brian Smith, Director of the Center for Transportation Studies at the University of Virginia. Appreciate getting my son through there, class of 2005, where Dr. Smith, not my son, is also the chair of the Department of Civil and Environmental Engineering. Dr. Smith was elected Fellow of the American Society of Civil Engineers in 2009 and is a recipient of many awards in the fields of transportation and engineering. Dr. Smith received his BS in Mechanical Engineering from Virginia Tech. I've got another one who was there. His MS in Systems Engineering from the University of Virginia, and his PhD in Civil Engineering from the University of Virginia. And I understand your daughter, Cecilia, is here today with you in the audience, so let me also welcome her here. And it's always nice to have here visiting, so welcome also. Our final witness today is Mr. Jeffrey Owens, Chief Technology Officer and Executive Vice President of Delphi Automotive, one of the world's largest automotive parts manufacturers. Mr. Owens has served in a variety of engineering, manufacturing, finance, and product line assignments, including as President of Delphi Asia Pacific from 2006 to 2009. Mr. Owens earned his bachelor's degree in engineering from Kettering University and his master's in business from Ball State University. He currently serves as the chairman of the Kettering University Board of Trustees. In order to allow time for discussion, we ask you to limit your testimony to 5 minutes, and your entire written statement will be made part of the record. Thank you, and I now recognize Mr. Winfrey for 5 minutes for his testimony.
Thank you, Chairwoman Comstock. Ranking Member Lipinski and members of the committee, thank you for the opportunity to appear before you today to discuss the Department of Transportation's Surface Transportation Research, Development, and Technology programs, also known as RD&T. We all recognize that results-driven transportation research and technology are essential for maximizing the federal investment in transportation infrastructure and operations. Our transportation system needs to be smarter, and that's why the department provided the Grow America Act, a bill that, at its core, shifts the foci of transportation funding discussion from short-term measures to long-term custodianship. We look forward to charting a path toward a common solution together. Secretary Anthony Foxx highlighted the challenges we face in his strategic framework entitled Beyond Traffic 2045, Trends and Choices. Beyond Traffic is a draft survey of the major forces shaping transportation and a discussion of the potential solutions that can be adopted to address those forces. It is not prescriptive, it doesn't advocate for specific policies, but it does underscore the critical decisions we're going to have to make, drawing on a variety of data, research, and analysis to frame key questions, such as, how can we avoid a future of crumbling infrastructure and gridlock traffic, where our transportation network constrains rather than enables our economy? How can we ensure that we are creating the right connections so that all of us can have the best opportunities to access jobs, goods, services, and each other? When Secretary Foxx unveiled the draft of Beyond Traffic in February, he invited the American public to join him in the discussion, to have a frank conversation about the shape, size, and condition of our transportation system and how it will meet the needs and goals of our nation for decades to come. And we are pleased that people across the country have answered his invitation. We've received hundreds of comments at events, through webinars, from social media, and on our website, which I also encourage you to visit at transportation.gov/beyondtraffic. Thought leaders, young professionals, and Americans from all walks of life continue to contribute to this effort and to raise tough questions about the future we all must build. One of the most important questions is, how will we encourage the development and adoption of new technologies that can make travel safer and more convenient? Innovative technologies can support safer and more efficient vehicles, infrastructure, logistics, and transportation services. New sources of travel data can improve traveler experience, support more efficient management, and inform investment decisions. Automation and robotics will influence all modes of transportation, improving infrastructure maintenance, travel safety, and enable commercial use of autonomous vehicles. The department currently invests almost $1.2 billion in transportation research, development, and technology activities. To address the challenges we face, the President's fiscal year 2016 budget request increases this investment by almost 30% to over $1.4 billion. The President's request directs research and technology investments to the priority areas highlighted in Beyond Traffic and other areas important to the transportation enterprise. So I'd like to provide a brief overview of these priorities, but note that my written testimony provides many more details. The department has a significant investment in vehicle-to-vehicle communication technologies, and vehicle automation innovations are developing rapidly, capturing the public's fancy. Grow America seeks to invest $935 million over 6 years in activities to advance vehicle automation and vehicle-to-vehicle technologies. The administration made accelerating deployment of V2V technologies and swiftly advancing a deployment framework for automated vehicles a priority, seeking $158 million for the Intelligent Transportation System research program in FY16, a 68% increase over enacted levels. Moreover, in May, Secretary Foxx directed the NHTSA to accelerate the timetable for its rulemaking on V2V technology in new vehicles. He also committed to the rapid testing of unlicensed devices, seeking to share the wireless spectrum used by V2V to ensure there is no interference to critical safety of life messages as soon as the production-ready devices are provided by industry. And he has asked NHTSA to make sure our regulatory framework promotes the deployment of proven traffic safety innovations in an effort to ensure an accelerated and safe deployment of these applications. So I'm certainly mindful of time. There is much more in my written testimony, but I would like to conclude by saying that I'm excited about the future of our surface transportation research programs. These programs are vital to achieving the safety, state of good repair, economic competitiveness, quality of life, and environmental sustainability goals of the U.S. Department of Transportation and the expectations of the American public. We are addressing serious issues and seeking tangible results for the benefit of all citizens and our nation's economy. And I look forward to your questions. Thank you.
Thank you. And I now recognize Dr. Meyer for 5 minutes to present his testimony.
Thank you, Madam Chair and members of the committee. As mentioned in my introduction, I am chairman of the Transportation Research Board's Research and Technology Coordinating Committee, which provides guidance on highway research technology programs and advanced research priorities to the Federal Highway Administration. In my past career, I've also been a director in the State Department of Transportation and responsible for a state transportation program, as well as for 15 years a director of one of the nation's largest university transportation research centers. So I bring a broad perspective in terms of some of the issues that you have before you. I'm going to summarize 2 Transportation Research Board reports that have focused on national transportation research, and then with the time that's available, I'll provide my own thoughts at the end. Special Report 313, called Framing Surface Transportation Research for the Nation's Future, was a report that focused on research efforts in other countries around the world, as well as non-transportation domestic organizations such as the Department of Agriculture as well as NASA. Based on the analysis, the committee for that report made the following key recommendations. One, they thought there should be a new framework for U.S. surface transportation research that's guided by key national stakeholders in transportation. To a large extent, the DOT strategic plan has started that direction. The recommendation was for the Secretary of Transportation should consider ways to strengthen the coordination of the transportation research within the DOT and, in fact, appoint what they called a chief scientist position within the DOT. Third recommendation, focus on making sure that there would be both basic and advanced applied research with regard to the program. And then finally, the U.S. DOT should continue its activities in terms of promoting knowledge transfer and dissemination. Special Report 313, called The Essential Federal Role in Highway Research and Innovation, focused on the Federal Highway Administration and its role in a national transportation program. The report observed, in fact, that the Federal Highway's Exploratory Advanced Research Program is the type of basic research that the committee itself was looking for. It focuses on such things as connected highway and vehicle system concepts, breakthrough concepts in material sciences, human behavior and travel choices, technology for assessing performance of the system as well as organizations, and new technology and advanced policies for energy and resource conservation. This is the type of research that we strongly recommended to Federal Highway as an RTCC, and in fact, they took that recommendation and implemented that program. The report concludes that, in fact, that the Federal Highway Administration is in a very unique position to take a long view in research in terms of our nation's highway system and to do advanced research that will, in fact, contribute to a vehicle-to-vehicle and vehicle-to-infrastructure program. With its national perspective, it can lead states in terms of developing and transferring tools and processes that can improve safety and system performance. And with its economies of scale in terms of having division offices in every state, it's uniquely positioned to support the implementation of innovations by states and local agencies, in particular developments relating to vehicle-to-infrastructure programs and standardization of projects and programs that come out of the Strategic Highway Research Program. So that summarizes in very general terms those 2 reports. Now, just my own observations, I think I could certainly congratulate the subcommittee on the theme for this hearing in terms of technology driving the future. My own experience in the field in a variety of positions has really shown that, in fact, technology is one of the driving forces of where we are today and will likely be in the future. So my own observations with regard to a national surface transportation research program follows. First, I do think the U.S. DOT does have a critical role to play in establishing a research framework that guides not only its own modal agencies' research programs, but also those that are under its area of responsibility, such as the University of Transportation's research program. I think this framework needs to recognize that it's not just government agencies that are doing research, it's the private sector, it's the universities, it's others, and that needs to be provided under kind of a guided framework in terms of what should happen. The interaction of vehicle and infrastructure in particular, I think, suggests a very strong role for the U.S. U.S. DOT in things like human factors research, as well as system performance and smart infrastructure. Third, this research portfolio should really combine both basic and applied research. One of the things that I've noticed in the field after many years is that basic research seems to be, well, that goes for National Science Foundation and applied goes to transportation, and I think that's a mistake. I think that the applied research community has a lot to offer in terms of understanding some of the basic concepts, the theories that underlie our research programs. Next, I believe that this base research program should be based on peer review. This is something that we discuss a lot. Both NSF as well as the Transportation Research Board has long experience in peer-reviewed types of reports, and I think that is the best way that we need to go forward as a nation. So, Madam Chair and members of the committee, I really thank you for the opportunity to present my ideas. As the committee has noted, technology is driving our transportation future, but I would suggest that, in fact, research and development are driving technology. And that is thus in the national interest to support, foster, and encourage the creativity that lays at the foundation of our technology future with 0 seconds left. Thank you.
Perfect. And I now recognize Dr. Smith for 5 minutes.
Chairwoman Comstock, Ranking Member Lipinski, and members of the committee, thank you for holding this hearing and inviting me to testify today. My name is Brian Smith, and I am the director of the University of Virginia Center for Transportation Studies. I appreciate the committee's focus on the role of the federal government in supporting research to tackle emerging transportation challenges. UVA CTS leads a wide range of research and education activities directly supporting local, state, and federal agencies, as well as the private sector. My testimony today will focus on the work of CTS and our new Mid-Atlantic Transportation Sustainability University Transportation Center, or MATS UTC for short, and how federal, state, and local engagement with and support for university research has improved the safety, efficiency, and sustainability of our nation's surface transportation system. UVA has a long history of working closely with local and state agencies, such as the Virginia Department of Transportation, or VDOT, to deliver applied research that advances their missions. In addition, we also develop the future leaders of the transportation industry and train over 2,000 VDOT and local agency professionals annually to take full advantage of rapidly changing technology. To complement the applied research, basic research is essential to create the advances and develop technologies that sustain an efficient, reliable, and cost-effective system. In particular, a strong federal transportation research program is crucial as the research community seeks to develop new technologies that take advantage of rapid advances in fields such as materials and information technology. For many states, including Virginia, the Federal University Transportation Centers, or UTC program, has played a key role in enabling a comprehensive program that balances both short-term applied research with higher risk, higher reward basic research focused on emerging challenges. The UTC program brings together federal and state resources to address critical regional needs that limited state resources could not address alone. The program is a small but highly leveraged federal program that successfully maximizes the support. I will now change and discuss the new MATS UTC, which has expanded our research and education capabilities at UVA. MATS UTC began operation last July and supports the surface transportation community in the United States with a focus on the Mid-Atlantic region. The objective of our work is to improve the environmental sustainability of surface transportation services. Our partners in the UTC are Virginia Tech, Old Dominion University, Marshall University, Morgan State University, and the University of Delaware. Like many UTCs, the MATS UTC program focuses on research, technology transfer, undergraduate and graduate education, training of practicing transportation professionals, and outreach to introduce opportunities in surface transportation and STEM fields to K-12 students, with a focus on traditionally underrepresented groups. We organize the MATS UTC program to bring together the region's researchers to work on teams to tackle complex problems. A key component of our program lies in soliciting proposals to competitively award funding to support multidisciplinary research that addresses the needs of the region and nation. Our research is reviewed by national experts in a peer review fashion. Our multimodal research program is focused on 5 critical areas: sustainable freight movement, coastal infrastructure resiliency, energy-efficient urban transportation, enhanced water quality management, and sustainable land use practices. U.S. DOT is integral to the operation of MATS UTC, both through the funding it provides and through close coordination with our team. MATS UTC also works closely with local and state transportation agencies to ensure that our research is responsive to local needs. Outside of MATS UTC, UVA continues to conduct research for the future surface transportation system. For example, UVA CTS supports the U.S. DOT as it invests in development of connected vehicle applications, which you've heard about a bit already, to provide connectivity between and among vehicles, infrastructure, and wireless devices, enabling safety, mobility, and environmental benefits. Our research is focused on using technology to allow DOTs to meet their missions more effectively and at lower costs. An example is a recent research project on pavement roughness measurement to support roadway maintenance. This work we did provides the potential for VDOT to improve their data collection while also saving about $2 million a year in monitoring costs. UVA CTS also frequently interacts with private sector to involve companies in applied research and to support rapid implementation of results. More detailed examples of technology transfer in our research is provided in my written testimony. UVA CTS is proud to have contributed to the development of transportation technology and to have developed leaders in the transportation industry. Thanks to federal investment in research, and particular long-term support of the critical UTC program, the country is well positioned to make our transportation system safer, more efficient, and sustainable. I appreciate the opportunity to provide testimony to the committee, and I am happy to answer questions later. Thank you.
Thank you. And now I recognize Mr. Owens for 5 minutes.
Okay, thank you, Chairwoman Comstock, Ranking Member Lipinski, and members of the Subcommittee on Research and Technology for giving me the opportunity to testify today on behalf of Delphi. As Chief Technology Officer, I'm responsible for Delphi's global engineering organization, our innovation strategies, and our advanced technologies. As a leading global supplier of electronics and technologies for automotive, for commercial vehicles, and other market segments, we invest more than $1.7 billion annually into engineering development initiatives and employ approximately 5,000 people in the U.S. Like the Science Committee, Delphi has a long history of dedication to technological innovation, culminating this April with the first autonomous vehicle cross-country drive. Are we okay to keep going? Okay. So let me pause to show a short video that highlights some of the Delphi technologies that made it possible. Okay, well, that was a very short video. So if we'd had a chance to see the video, what you would have seen would have been a replay of our coast-to-coast drive that we did back in April. So we outfitted an Audi Q5, if you will, drove 3,400 miles through 15 states, went from San Francisco to New York City. We had a car that operated autonomously 99% of the time. So we had a bunch of film clips in there of the car going through the variety of states across the United States. Some of the things that it encountered, like some of the bridge structures, the roundabouts, the lane markings that were different state to state. So it was a little bit of color on that. But for us, we installed a broad suite of our active safety technologies on like I said, a 2014 Audi Q5. We had the latest technology. It included radars, cameras, LiDARs, V2X, GPS, and driver state monitoring. And driver state monitoring, which allows the vehicle to monitor the availability of the driver in situations where a takeover may be necessary. So it looks like we're going.
Yeah, no, we'd love to see it, so.
So there's some narration that went with this, basically detailing that the sensors acts like your eyes and ears and your touch as a human being. It embeds into the infrastructure of the vehicle, makes the same decisions that you would make as a driver, and we were able to do it 99% of the time autonomous. So one of our primary lessons from the success of this drive is that we have available today in the consumer marketplace technology that includes forward collision warning, collision imminent braking, lane departure warning, and blind spot detection that, if more broadly adopted, will dramatically reduce deaths and injuries on our roads. Today's active safety technologies operate well enough to drive a car on its own 99% of the time. And these technologies, when paired with a driver, can address one of the greatest causes of premature deaths, and that's traffic accidents. Through consumer-based adoption of active safety technology, 11,000 lives can be saved annually without a technology mandate, without a broad new program, and without regulatory requirements. Vehicle deaths in the United States have declined with widespread adoption of passive safety technologies such as seat belts and airbags, but progress towards further death and injury reduction has stalled. We still have 33,000 deaths annually in the United States and over 200,000 serious injuries each year on our roadways. So government and industry groups have studied the benefits of these technologies for well over a decade. A study by the Insurance Institute for Highway Safety, the IIHS, states that a 31% reduction in deaths is possible. So once again, that's more than 11,000 lives saved per year with full deployment of active safety systems throughout the vehicle fleet. So in conclusion, the driving public wants vehicles with improved safety features. As the cross-country drive demonstrated anew, the technologies are currently available. However, it's difficult for consumers to understand their value. And a key consumer awareness tool is DOT's New Car Assessment Program, or NCAP, which includes a 5-star rating and all new vehicle stickers. Already, both the insurance industry, through its IIHS Safety Pick Plus program, and the European Union, through the Euro NCAP, incorporate active safety into their safety ratings. So today, DOT's NCAP does not include active safety in 5-star rating system, and I feel the DOT should amend the NCAP to require 5-star rating. In the 5-star rating system, it should include active safety features like collision avoidance technology. So this week, Representatives Rokita and Blumenauer introduced the Safety Through Informed Consumers Act, or stickers, which requires NHTSA to incorporate active safety into their safety rating system within a year. The legislation provides the best path forward for wide-scale adoption of active safety by giving consumers information in a form they can use and to which the market will respond. The sooner we increase consumer awareness, the sooner we can lower fatality rates, the sooner we move towards cars that can drive safely. Today, with a driver behind the wheel, and in the future, maybe on their own. So again, thank you for the opportunity to address the subcommittee, and I look forward to questions.
Thank you. I now recognize myself for questions, for 5-minute question rounds we'll have. Let's see. Okay, I wanted to follow up with Mr. Owens on how, with the bill you just mentioned, would that be expected to also bring the costs of insurance down for people who then are using the technology, and do you have estimates on that?
Yeah, I don't have estimates. I can say anecdotally, insurance rates are starting to recognize. I mean, you have to have enough data to get into the actuarial tables. Europe leads the United States here by implementing the 5-star a few years ago. So in Europe, with a Volvo, for example, you buy your insurance policy when you buy your car, 3-year policy typically, you get 1 year free in Europe if you have the active safety portfolio on the Volvo. So starting to have a benefit, but they'll have to accumulate the data to know exactly what that's going to be.
Right, so you'd have saving lives and then saving money potentially. So
Exactly.
Nice combination there, great. Okay, now, like with that case, part of getting more dollars for research and development is for us to actually see real life results. So Secretary Winfrey, I wanted to ask about state and local transportation agencies, deploy new technologies, such as systems that provide travelers with traffic information, decreasing congestion, when they're telling you what's ahead and really, transferring more of the information, as well as, we have our cell phones now, when we use them appropriately, that will tell us where the transportation bottlenecks are. How, to what extent is DOT communicating the results of your research on these new technologies to the states and localities so they can then implement it? And then what kind of tracking do you do of that implementation?
I would say it's principally through two different mechanisms. One is the DOT Research Hub, and that's a web-based portal where all research conducted at the department is posted and made available to the public. That's certainly the most direct means for that kind of information to be disseminated. But I would also say, you know, we are hugely supportive of open government and of the making access to research results available to the public. We've received a memo from the White House Office of Science and Technology Policy for making research results available to the public. So by providing access through those two portals, state and local DOTs have access to the research data of federal investment. Can we track it? I would say our best tracking mechanism is following the hits and the results that we get on the research hub, but there isn't a formal means of dialogue with state and local DOTs on those issues.
Okay. Are they given like best practices information? There's seminars, you know, efforts to transfer that information at various levels? And maybe if the other witnesses have, you know, I see you're nodding, so if there's something where you can, if the others would like to jump in to address some ideas on that.
Well, I think there's been a long history of interaction between the U.S. DOT and Federal Highway, in particular on the highway side, with AASHTO, the American Association of Highway Transportation Officials, as well as through the Transportation Research Board. There are, I think, a lot of examples of where there are research briefs, there's discussions, there's conferences, there's workshops. So I think there's a pretty good dissemination of research results. The issue, of course, is that there's so much research going on, as I say in my written testimony. There's so many groups doing research that sometimes things happen that you're not quite aware of that have a real impact, like your phone, for example, as you mentioned. So my sense is that there is a pretty good relationship going on between disseminating the research results out, whether it be through universities or through professional organizations or through groups like AASHTO.
Just to briefly add to that, one of I think the strengths of the UTC program is that the universities can serve as that kind of conduit to take the research that's been sponsored at the federal level. We know the people in our state and local agencies. We talk to them just informally. We have courses specifically to try to take the results from research and make it more tangible and usable. So we don't just say, here's a paper, read it. We really try to find ways to make it real so that they can implement it, and that's an important part of the UTC program. Great,
thank you. I see my time is just about up, so I'll recognize Ranking Member Mr. Lipinski.
Thank you. So many questions here. Let me just quickly jump into it. First, for Mr. Winfrey, Secretary Winfrey, and Dr. Meyer, a substantial share of transportation research is conducted, as I mentioned in the opening statement, by federal agencies such as NASA, NSF, DOE, and DOD. For example, Argonne National Lab, which is in my district, conducts transportation systems resilience modeling using their supercomputers. So how does the U.S. DOT coordinate with these agencies to make use of resources like supercomputers? And what can be done to develop substantive interactions with other federal agencies?
Thank you for the question, Mr. Lipinski. DOT works across the enterprise from a federal agency perspective. We work with many different agencies and departments depending on the issue at hand. So, for example, workforce development, which is a key role that we play at the department. We partnered with the Department of Labor, the Department of Education to have a continuum with respect to renewable energy and sustainable transportation. We work very closely with the Department of Energy. Just yesterday, I spoke with the NASA Jet Propulsion Laboratory about combining our knowledge to research automation and looking forward to, unmanned aerial devices and other kinds of technology. So JPL is one of our key partners there, or will be as well. So the best way to put it is we're aware of what's going on across government. We work collaboratively with those agencies and departments in many different spaces. We partner with the Department of Defense in maintaining the GPS satellite constellation. So all of these different technologies are resident at DOT. We're aware of across government and work collaboratively with other organizations.
Thank you. Dr. Meyer?
Thank you, Congressman. My sense on this is that much of the research that's done at national laboratories, for example, in the transportation area is often done under contract with the DOT, so the DOT is very much aware of it. What doesn't happen, in my opinion, is that there's a lot of work that's been done at Argonne and Los Alamos and others that have relationships to transportation, but they didn't originate from the transportation community, so to speak, or from the DOT. And we kind of find out about them, after the fact type of stuff. And that goes back to my testimony about having this new framework, this research framework that kind of lays out what it is that we as a nation really need to be focusing on with regard to key ideas, key thoughts, key research concepts. And then seeing what part everyone has to play. I've seen work that's been done by EPA, for example, that folks at DOT weren't even aware of, but directly related to the transportation group. So I have no doubt that there is coordination and there's discussion going on. But given a government the size of our government, things do happen out there from different sources that I think could be better coordinated, quite frankly.
Thank you. Next question. I'd like to go into this more, but a simple yes or no, probably just with limited time. I'm hoping for a particular answer. I think I'll get it. The National Freight Cooperative Research Program was eliminated in MAP 21. So I want to ask Secretary Winfrey and Dr. Meyer, would reinstalling this program help inform national freight strategy?
Yes, and we've requested that in Grow America.
And I cannot agree more with that. I think it's
microphone.
Oh, I'm sorry. I thought mine was on. I can't agree more with that. It's a big yes. I was shocked that, in fact, it was deauthorized or whatever the term was. I think it's a very valuable program and should be reinstituted.
Right, thank you. And last for Mr. Owens and Secretary Winfrey. Mr. Owens, Delphi is at the forefront of demonstrating the technology that's available. V2V will be rolling out next year with GM and others, and self-driving cars are testing out extremely well. So far, these two initiatives are running almost independently. I want to ask, do you believe that autonomous driving can be made safer by using V2X technology? And what should be done to bring the two streams of research together? And let me throw in this one other part. If anyone wants to give an answer, one of the most fascinating things to me was when I had this panel out in the Bay Area, Silicon Valley, is how much more efficient can our system get with technology, the current road system we have right now. So, Mr. Owens, I don't have much time, so
yeah,
whatever you can add to.
So, first of all, I don't consider that those are two separate initiatives. If you look at our vehicle that we put on the road, it had all of the technologies, including V2V and V2X, on there. We'll be first to market next year with General Motors with V2V. It's a matter of building blocks. To get to a fully automated vehicle or even semi-levels of automation, you take the technology that's available and ready today. Active safety is ready today. Vehicle-to-vehicle technology is not, there's nothing more to invent there. It's a matter of implementation, but it's not on the road today. As it goes on the road, you've got a radar system, you've got a vision system, you get a very compelling scenario analysis in front of the vehicle to help the vehicle decide what actions to take, where the threats are. You add to that then when it's ready, vehicle-to-vehicle, it's a wonderful addition to those building blocks to help complete that scenario of what's around the vehicle, even more so through the intersection on farther down the road. So very complementary, again, on the roadmap to a fully automated vehicle. I consider all those technologies critical.
Well, let me, because I'm over time already, you go, instead of Secretary Winfrey adding to that, does anyone want to give an estimate of how much more efficient? Because I have heard between 2 times and 4 times more efficient. That is, we could put that many more vehicles on our current road system if we have completely autonomous vehicles with all the technology, gets V2X is out there. How much more efficient can we get?
Well,
I'm not going to hold you to this.
Yeah, I can give you the data that I've read as others have. A report just came out from one of the consulting groups 2 weeks ago that said you require 40% less vehicles. you require 80% less parking. I mean, those kinds of statistics. So I can't validate the numbers, but that's, I mean, generally that would be in the ballpark of what you could expect. I can tell you closer in before you get to automated, if you put even adaptive cruise control, being able to automatically set the headway, just that, 3 to 5% pickup in fuel economy if you just have 1 out of 4 cars that have it on the highway. If you get 2 cars out of 4 that have it on the highway, you're in the 5 to 8% pickup because you have smoother flow, you have less gridlock, you have less of the accordion effect when traffic stacks up. So I think those statistics are pretty compelling even in the near term before you even get to autonomous.
Well, I'll yield back now. I'd love to hear more, but I've gone way over. Thank you, Chairwoman.
Thank you, and Mr. Molinar, I now recognize.
Thank you, Madam Chair, and I want to thank all of you for sharing your insights with the committee, and I've learned a lot already today, so appreciate that. Secretary Winfrey, I wanted you, if you could, to elaborate a little bit. You mentioned in your testimony some of the work being done in Ann Arbor, and as a Michigan representative, you know, I'm aware of some of the work they're doing. They've created a mobility transformation facility and to test how autonomous vehicles respond in real-world situations. And what I was hoping you might do is just elaborate on how you work with them in this regard, and I know there are some plans to expand also through the Detroit corridor.
Yes, thank you for the question. And the first thing I would point out is that I'm extraordinarily pleased to be here with UTC representatives. As they've both mentioned, the UTC program is extraordinarily strong in supporting our transportation initiatives. So to carry that further, we're working with the University of Michigan, another one of our UTCs, on connected vehicle technologies, and they are putting together the Southeast Michigan connected corridor. So from Novi past Detroit, that will be a roadway test bed, kind of a living laboratory that looks at connected vehicles, vehicle-to-vehicle communications, vehicle to infrastructure, everything from road weather to signal phase and timing. So it will be, again, a living platform that the University of Michigan, in the conduct of our connected vehicle safety pilot, first developed. So the safety pilot was a 3,000 vehicle circulating in and around Ann Arbor, giving us that rich data that was used to inform the NHTSA ANPRM. So we're very supportive on the research side of where NHTSA wants to go with connected vehicle technology, and all this is made possible by our strong partnership with the University of Michigan.
Wonderful, thank you. And I also wondered if you might comment on some of the policy issues for autonomous vehicles and how the research at the universities has contributed towards, you know, clarifying some of the policy issues. And then one in particular I was hoping you might talk about is I've heard from individuals about spectrum availability for vehicle-to-vehicle technology, and that on May 13th, Secretary of Fox announced plans to accelerate the rulemaking proceeding, and I don't know all the specifics of that, but I guess the core question I have is that going to require an additional funding request, or do you feel that funds are sufficient to accelerate that process?
With respect to the first question, the question about spectrum is quite lengthy. So maybe I'll start there first because it's an important question for me to address. V2V operates in the 5.9 gigahertz spectrum. Right now, the Wi-Fi industry is interested in sharing that spectrum for uni devices, unlicensed national information infrastructure devices. The problem is we can't tolerate interference in critical safety of life applications. DSRC communicates 10 times per second relative speed, steering wheel position, brake force, et cetera, of what a vehicle that's potentially in a collision scenario is doing. So it gives drivers advance warning to engage in invasive or preventive maneuvers and avoid crashes. As we know, we have 32,719 fatalities on our roadways, and that number is unacceptably high, as Mr. Owens has pointed out. So this is a critical technology that will really reduce and address those crash scenarios. We're not averse to testing, but again, we need devices, and the Wi-Fi industry has not produced 5.9 gigahertz Wi-Fi devices for us to test in a real-world scenario. We have a current testing platform and test bed in Cheltenham, Maryland, at the DHS Federal Law Enforcement Training Facility, where we'll be able to engage in testing as soon as devices are delivered. So that's what Secretary Fox said when he said that, look, we're going to move forward with our rulemaking with respect to V2V. We are willing to work with industry on testing to see whether or not there is harmful interference. We think that within 12 months, we'll have data that will let us know up or down whether or not sharing can be tolerated. But none of that can start until we get devices. So we're moving on dual tracks. We're full speed ahead for the NHTSA NPRM, but we're also interested in working with industry should they provide the devices that we need.
Thank you very much. Thank you, Madam Chair.
Thank you. And I now recognize Mr. Westerman.
Thank you, Madam Chair, and I too appreciate you all coming and testifying today. This is the kind of stuff engineers like to listen to. So my first question is to Secretary Winfrey regarding research, development, and technology. How does the Office of the Assistant Secretary for Research and Technology identify duplicative research programs at the Department of Transportation? And if redundancies are identified, how are they addressed?
Thank you for the question. The reason this organization was stood up, and you may remember the original RITA, the Research and Innovative Technology Administration. My office is that office, but we're now elevated into the office of the Secretary. Our principal role is research coordination across the department, and the means in which we affect that are through monthly RD&T planning team meetings. So we bring together the associate administrators of research across the department's operating administrations, and on a monthly basis engage them in a discourse and dialogue about what each research organization is working on. And just by getting us out of those stovepipes and having those discussions has really brought to light a lot of the activities that are going on. It's helped us reduce or address whether or not there are duplicative research programs. As custodians of taxpayer dollars, we're extraordinarily sensitive to the need and the responsibility to be as fiscally responsible as possible. So that's the principal means for us to do that. We also have an RD&T planning council executive committee, and those are where the administrators across the department are brought together as well to talk about what their individual organizations are doing. So just by staying closely engaged with the research community across the department is the best way for us to tackle that issue.
All right. Next question for Dr. Smith and Dr. Meyer. With the issues with funding for transportation, when conducting research for transportation systems, how much emphasis is placed on life cycle cost, initial construction cost, and overall economic impact of designs as it relates to earthwork and base preparation and pavement systems and things like bridge and overpass structures?
That is a great engineering question. Thank you for that. As fellow engineer, I take it. Several years ago, I don't know when the specific date was, the DOT actually issued a policy saying that you really need to do life cycle costing now in terms of federal projects, for example. And so the research part of it is very much looking at when you look at new materials, composite materials, nanotechnology, all that type of stuff. We are looking at, from a research perspective, over the total life cycle in terms of the replacement, recycling, the O&M during the life of it, as well as the initial capital and the recapitalization as you go through. So I would say that most research that deals with the structure side, the material side, the equipment technology side is very much focusing on the issue of life cycle costing. That's just the way that we look at benefit cost now these days.
So Can you give some examples of recent developments in highway transportation that have resulted from federally funded research that have increased our transportation durability and reduced life cycle costs?
Sure. I think the obvious example is the pavement research that was done in terms of so-called super pave, I guess is the phrase for it, where we went to Europe and other places to see how they did certain things, came back and kind of recomposed how we did our pavement surfaces and developed pavement materials and pavement construction technologies that made the life of the pavement much longer. And that was funded through I think it was through DOT, through the SHARP program, or through the Transportation Research Board, but the money came to a large extent from the Department of Transportation. So I think that's a clear example in terms of how research has really led to longer lived, longer life, if you will, with regard to materials that every state DOT in the country uses.
So is the real apple out there still in materials? You mentioned nanotechnology. What can we expect in the future? Because, you know, you think about how long highway systems have been analyzed and researched.
Yep.
What's left to gain?
Well, and you know, as a former researcher, there's always a lot of apples, you know, that you want to eat and bite into. I certainly believe that materials is an area where there's a lot yet to gain in terms of higher strength, lower weight type of materials, the so-called composites and nanotechnology. And what we've been talking about before is the operations of the system, the V2V, V2I type of stuff, which I do think there's tremendous efficiencies and tremendous additional effectiveness that we can get out of our transportation systems by looking at how to better manage through technology. So that's another area where I think we can really gain a lot in terms of research and technology development. But materials certainly is one where I think we need to continue our research and technology to get those efficiencies out of the materials.
I think I'm out of time, Madam Chair.
I now recognize Mr. Palmer.
Thank you, Madam Chairman. Couple of questions. Mr. Winfrey, for fiscal year 2016 budget request for the National Highway Traffic Safety Administration vehicle research and analysis programs was $39.7 million to be used to conduct motor vehicle safety research and to develop advanced vehicle safety technology. Does this research duplicate research being done by the automakers and other private entities?
I would say it's complementary. You know, those are vexing issues, and they're looking at it from different perspectives. Certainly, the OEMs have a vested interest in those technologies for protecting passengers, as well as, you know, their ultimate customers down the line. But NHTSA looks at it from a safety perspective. We are a safety-first organization, and those technologies, we believe, are the best means for kind of a holistic view about occupant safety. One of the things we talk about at DOT is the first 50 years have been focused on having vehicle occupants survive crashes. The next 50 will be about avoiding crashes altogether. So all of that is part of a continuum of research at NHTSA.
Well, I was going to ask something else, but because you put so much emphasis on vehicle safety as opposed to infrastructure, role in that, and I do think there's a role, and I'll come to Mr. Meyer on this in a moment. The President is proposing the corporate auto fuel economy standards be 35.5 miles per gallon by 2016 and 54.5 by 2025. Yet the research shows that, and I think the National Highway Safety Standards Board made this projection that for every 100 pounds you reduce the weight of a vehicle, that increases the highway fatalities by just about 5%. And there's research and data out there that indicates that thousands of people have died as a result of being in lighter vehicles that were basically forced upon the automobile industry. How do you respond to that, and what does the highway, what does your group, what are you doing in the context of trying to improve vehicle safety from that perspective when you seem to be working, the ends that you're trying to get to seem to be at odds with each other?
No, thank you for that, and unfortunately I'm not as expert as I should be in responding to that question, so I would have to defer perhaps to questions for the record. But one thing I would say, you know, if you look at the lightweighting of vehicles in auto racing concept, you know, they're able to construct vehicles that are withstanding crashes, you know, significantly more velocity than on our roadways today. So there are technologies available, there are materials available that will make for lightweight but strong vehicles that will protect occupants.
I appreciate that, but there's basic physics involved here, and you know, while you're trying to work toward a solution toward this, there's still people going to die because of these government-imposed standards. Mr. Meyer, you talked a little bit about the composite materials and things that you're using on for highway services. What kind of research is out there on that end that will not only make it less expensive to for highway construction, but safer in the context of vehicle transportation?
Well, I'm not that familiar with vehicle composite material, which is what Mr. Winfrey was talking about in terms of the vehicles themselves. But on the infrastructure side, there's been a large amount of research on structures, bridges, for example, being designed and built out of composite materials so that, in fact, they're have longer lives and they don't have to be maintained as much. With regard to the safety element to it, I wouldn't say it's so much on the composite material side as it is the types of materials that you put into roads, intersections, and the interface with the vehicle and the tires that, in fact, to make the actual movement of the vehicle along that pavement much safer in terms of wet pavement and that type of stuff. So there's a lot of work that's been done on that. I wouldn't, again, call that composite materials, but it's a different types of materials research. Safety is a huge focus for a lot of universities as well as government agencies on the material side as well as on the operations side, and as you mentioned, also on the vehicle side. So I think that one can certainly point to a fair amount of research that I'm aware of, at least that on the material side, that relates directly to safe movement of vehicles and trucks.
Well, let me just conclude my time by going back to the original question about the duplication of research, and I think in our current budget situation, we want to eliminate as much duplication as we can, and there's excellent research being done at Auburn University at the National Center for Asphalt Technology. So in the event that you're not familiar with that, I encourage you to talk with them about surface transportation and highway safety. Thank you, Madam Chairman.
Thank you. And I just want to thank our witnesses today for your testimony and for really the exciting innovations that you all are working on, and like to invite you to continue to share any information or developments as you see and to inform the committee. And we very much appreciate you being here this morning, and thank you for the early start too. We have, as you may know, some busy votes ahead of us today. So thank you very much. The record will remain open for 2 weeks for additional comments and written questions from members. And again, we really appreciate your valuable testimony, insight, and the spirit of innovation reflected here this morning. Thanks so much. And the hearing is adjourned. Mm-hmm.